given the piecewise defined function f of x, and we are told that if x is less than 3, f of x is equal to x squared plus a minus 3 times x minus 3a divided by x minus 3. And if x is greater than or equal to 3, we're given that f of x is equal to a squared times e to the power of x minus 3 plus 3 times a times the cosine of pi times x minus 3 plus the natural log of a plus 5 times the sine of pi times x minus 3 minus 4x. Now, what we want to do is we want to find all real values of a for which f of x is continuous for all real numbers x. So essentially, we want a really smooth function that doesn't do that, let's be clear. We want a really smooth function, no sharp corners like that, all just smooth. And that is what I would say is if we were in like 4th grade. What's the actual definition of continuity? I don't know how to say that word, to be honest. I should know that. Well, f must be defined at c. Get a better marker. The limit as x goes to c from the right of f of x must be equal to the limit as x goes to c from the left of f of x. Those both have to converge to the same limit L, and 3, limit as x goes to c of f of x must be equal to f evaluated at c. These are our 3 conditions for a continuous function. So let's think about what this tells us for our function. Our bottom family of functions right here, they're all continuous no matter the value of a. Whatever a you plug in, this would be continuous. And for the top right here, well, it's continuous everywhere no matter the value of a, except down here we have a discontinuity when x is equal to 3. And you can see that's going to be a little tricky because we're kind of working around the number 3 here. So what we can actually do is we can evaluate the left-hand and right-hand limit as x goes to 3, and then set them equal, because that's our condition for being continuous. So let's take the limit as x goes to 3 of x squared plus a minus 3 times x minus 3a divided by x minus 3. So if we plug in 3 here, you can see we'll get a 0 at the bottom. So what we're going to do is we're going to factor. Now, if we recognize the form right here, we can actually see that this is the same as x minus 3 times x plus a. Because our coefficient for x right here is the same as the sum of these two values. And then this right here is x squared, this right here is minus 3 times a. That is exactly what we have on the top here. And at the bottom, we also have an x minus 3. So we can cancel, and we get that this original limit is simply equal to the limit as x goes to 3 of x plus a. So we can plug in 3, and we get that this limit, and we'll put a negative here, just so we know which one we're talking about. This limit is equal to 3 plus a. And on the bottom, we can actually simply plug in 3. That will make meeting our conditions easier. So we have a squared times e to the x minus 3, which is going to be 3 minus 3, so e to the 0, so that's just times 1, plus 3 times a, plus the cosine of pi times x minus 3. Plug in 3 there, and we're going to get the cosine of 0, which is just 1. Then we add the natural log of a plus 5, and we multiply, again, by the sine of pi, so the sine of 0, so that's times 0. And then we subtract 4x, which is going to be 4 times 3, so minus 12. So this whole term right here goes away, and now we can set these two equal. We get that 3 plus a is going to be equal to a squared plus 3a minus 12. And this simplifies to a squared plus 2a minus 15, and now this is going to be equal to 0, and this is the same as a minus 3 times a plus 5 equaling 0. So we get our two values for a to be 3 and negative 5. So we want to find all real values of a for which f of x is continuous for all real numbers x. Well, we have our answer. So this is our solution set for a, right? Well, this is actually not correct. And the reason for that is, let's see what happens when we try to plug in negative 5 to our bottom expression. This natural log term becomes a plus 5, so it becomes the natural log of negative 5 plus 5, or the natural log of 0. And this diverges to infinity, and it is not, that makes this function discontinuous. So our only solution here that actually works is a equals 3. So we don't have a solution set. We actually have that the only value that works is a equals 3, which is really nice considering that this whole thing was kind of centered around the number 3. It's kind of elegant that it comes out to be 3.